Okay, thank you for the invitation, Matthias, and thank you for organizing this conference. It's already been super interesting, super nice days. I would like now to present a paper which is joint with Johannes Haushofer and Jeremy Shapiro. And the paper is on the income elasticity for food. So the responses to income changes in developing countries are of significant interest to policymakers in general. And particularly, there has been quite a bit of focus on the response on food consumption. And I get back to some of the motivation for that in a few slides. But of course, in general, we're interested in nutrition because it could be important for achievements by children and many other things, productivity in the society more generally. But estimating these responses are extremely challenging if you want to estimate them off observational data. So, of course, we know that there are many problems with this. So in cross-sections, you have the problem of selection and sorting. So people across the income distribution may be different in many ways. And if you look at time, variation over time, often when you have an income change, it comes together with other changes in the society. So it comes together with productivity changes or wage changes in general. So findings from observational data may be subject to reverse causality. It may be that actually what you eat matters for how much you earn. And it may also be that other factors influence both the consumption of food and income. Say illness, it could give you a shock to your productivity and your income. It could also make you spend money on medicine instead of other things, so it could potentially crowd out food consumption. It could also be that if you're ill, you actually need more calories, and hence you actually need to spend more on food relative to other things. So we see all these potential confounding factors and the challenges when it comes to observational data. So now to why many have been interested in nutrition particularly is this idea that was discussed a lot in the 80s from theoretical models. So a model of Dasgupta and Ray suggested that there could be this nutritional-based poverty trap. And this has been challenged, this theoretical idea has been challenged from empirical findings, and we'll go back to this and actually investigate it with what we think is a more solid identification empirically, okay? So just to remind you, if you remember this discussion about the nutrition-based poverty trap, so the idea is that consider that the income in period T plus 1 is a function of your work capacity in this same period. And then again, you assume that this work capacity is a function of what nutrition you had in the last period. So what you were eating the last month actually matters for how much you can produce today and how much you will earn today. And then what you were eating the last month is again a function of what you were earning last month, what you had available in your budget, meaning that you get this function where income of today is a function of income in a previous period. Okay, so you can write this up in the following way. So you could think that income in period T plus 1 is a function of nutrition in time T, and then this nutrition in time T is again a function G of what you earned in period T. Okay, so then whether we have a potential poverty trap or not depends on the functional form of these F function and the G function. So if you write then the relationship between income from work in period T plus 1 and income from work in period T, it really depends on this shape. So if you have an area where this gradient is larger than 1, then you have a potential poverty trap. So it could be that even if you start up here or you give a push to your income, so say we have a transfer scheme or we have some kind of intervention where we actually push people up, it would, through this thinking and through this simple model and functional form assumptions, make you end up back in this X anyway. So this is like a poverty trap and a nutrition-based poverty trap. Okay, so what is essential, of course, is then the derivatives of these functions. So this is super simple math, so I won't spend much more time on this, but the thing is that you can write this up as a product of two elasticities. So you can write this up as a product of the income elasticity for food and nutrition elasticity as a function of income, right? So how nutrition is affected by income. So in order for a potential nutrition-based poverty to occur, you need the product of these two elasticities to be larger than one. And this has sort of motivated some of the empirical literature on this. So we have some empirical studies on the income elasticity for food. And the claim is that this elasticity is so far below 1 that it's very unlikely that a nutrition-based poverty exists. So it's almost been sort of rejected by the empirical literature because of this. And Deaton and Durst would come up with elasticities for calories, which is about 0.4, so it's far below 1. Others have come up with elasticities 0.6 for food consumption, and others have even shown in RCTs that there is no change in food consumption, even if you give transfers, conditional cash transfers. Okay. So what do we do? So we have a random variation in income. So we actually drop money on people. So this is part of the Give Directly program that Haushofer and Shapiro were sort of leading, and they already have an article, so I should refer to that, which explains more in detail this program. But as part of this program, we actually get results when we drop money on people. We have detailed information on consumption on food, different food categories, and we can also calculate nutrients. So here we can actually look at when we drop money on people, what happens to nutrition. And the program, many of you may know it already. Between 2011 and 2013, the Give Directly sent unconditional cash transfers. And these conditional cash transfers were big, okay? So on average, they amounted to 2 times the per capita income in the area. So this is a huge shock to those who were dropped people on them. And it's explicitly described as fully unconditional. And this is super important here because, of course, we have many RCTs that try to influence nutrition. But very often they come with either conditionality or some other kind of intervention, so an educational program on nutrition or something like that. So here it's extremely important that it's just an unconditional cash transfer with no other training sessions, okay? So this is a short-time windfall, either a lump sum or a monthly transfer. And it was randomly selected control and treatment households. And I'll explain in detail the randomization, how that was done. But the idea is that we can look at an exogenous change in income and use all these observational data from surveys on consumption and this shock in income to identify this elasticity. So it's only one of the elasticities, right? But people have focused a lot on this one elasticity. So it's still an open question about this other elasticity. Okay, so this is the Give Directly Rariera district in Kenya. I won't say a lot about the program. The program identified 120 villages, and the eligibility criterion was actually that they didn't have, so they did have a thatched roof, these households that were eligible. And in the villages that they identified in this region where most of the eligible households were living, that's how they selected the villages, 1,500 eligible households were selected because they did have a thatched roof. Okay, so the randomization, so there were 60 villages that are pure control, so no transfer, only a survey. And there are 60 villages, which is sort of treatment villages, but only half of the population, only half of the households in these villages were actually treated with the UCT. Okay, so then there are 3 treatment arms. And this won't be very important for what I'm going to report here, but I want to mention it for completeness. So there was a randomization whether there was the woman or the man who would receive the transfer, whether it was a lump sum transfer or monthly transfer, and whether it was a large or a small transfer. And this last thing, of course, we can use because we want that kind of variation, so that we use. But the other, I can just say that now up front, that there is no difference in the other treatment arms, so I will only focus on the aggregate results. Okay. So both treated and control households were surveyed. So in the treated villages, so those that were not pure control villages, these households were interviewed at baseline and endline. In the pure control households, we only have endline survey. And that will actually give some directions for what we can do empirically. So we have detailed expenditure on food categories, and then we calculate nutrients from these nutrient tables. And this is UN source for Africa, so that may matter a little bit. We don't have a Kenya-specific nutrient table, but we use for Africa. Yeah, and then we can construct prices. So we have prices at endline. We need to construct prices for baseline using the CPI and some kind of aggregation. We use the stone, where we use weights from the household consumption. But that also will turn out not to matter too much, this price control. But for completeness, again, I just mentioned it. Okay, so we estimate this income elasticity using the levels. So just looking at the endline consumption and using the UCT as an instrument. We also look at first differences. So we thought when we wrote the pre-plan that this was really a good idea. So we said we would do both for two reasons. So first, of course, you can get rid of a lot of household-specific heterogeneity when you look at first differences. Also, we thought that in the difference specification, the UCT itself is a more sort of direct, it's a better instrument. It's a stronger instrument because it is sort of the change in the income. Actually, of course, the downside of the first difference is that we cannot use the pure control villages. So now we are not so sure any longer which we trust more, but I will present both, and they are actually very similar, which may be comforting. Okay, so then I will present, which is important, and I would say one of the two main results of this paper is that we compare the experimental to the non-experimental. Yeah. Then we also pre-specified that we would have these different functional forms and different systems. So we also estimate a full demand system, a Q8 and a linearized version of that. However, there are two reasons why I will focus on the linear system today, and we will also do it in the paper. And first, it's that it doesn't seem when we plot this semi-parametrically that it is actually nonlinear. And the original article by Banks, Blundell, Lubel also couldn't reject the linear form for food consumption, right? So it sort of seems that this is not implausible to assume that we sort of see a log linear relationship. It's also that we have a weak instrument only when we use the quadratic terms in there. So the only instrument we have in addition to the UCT is UCT squared. And I mean, in principle, that would work, so it's okay. We pre-specified we would use it, but when we look at it with the data, we see that this instrument is really weak. So we can produce it, it goes through it. The results are not so different, but I will show you the results from the linear estimation today. Okay, so here is the semi-parametric, yeah. Yeah, so this is, yeah, so we could check that a little bit. So what we want to, in some sense, that's more of a mechanism, right? Because we want to know when you drop money on people, when they get a transfer, what happens to their food consumption. So in some sense, I mean, whether that's true or not, it's still interesting to just look at what happens to their food consumption, yeah. But this is part of the reason why we also want to have the level effect and not only the first differences, but because we think that these households that weren't treated in the treated villages are more of spillover households. So there could be a lot of transfers, there could be a lot of sort of spillovers, which is not also transfers, right? So that's sort of why we also want to run without this variation. Yeah. Okay, so this is the semi-parametric plot. So we take first we difference away the linear effects from the controls in the household, so the background characteristics of the households, and then we plot the residual budget share for food on log expenditure. And as you see, as in many studies, I mean, it's a little bit unclear, the functional form for the poorest, but the confidence bounds are also wide. So for sure, it's not, the linear functional form is not rejected here. So that's what we will continue using. So this is for the nutrients. So there we pre-specified a different sort of estimation where we had log on log. So we didn't put it through the whole demand system because it doesn't make sense in the same way. We don't have prices for these nutrients particularly. So this is just log and log. And again, you see that the linear functional form seems quite possible. OK. So these are the results. So this is the level equation. This is the first difference equation. And it may be very hard for you to read. But what I want you to take away is that, so first of all, I can say what is in the table. So we can find the elasticity evaluated at the mean, evaluated at the median. We could also find all the individual household elasticities and then take the mean and the median in that distribution, right? So we do all of that, and it doesn't look very differently. So if you can't read it, I'll just say what it is. So this is 0.895. This is the elasticity for food, income elasticity for food, estimated with the IV. So this is the experimental. And at the median is 0.096, and if you just take the mean over all household-specific elasticities, you get 0.884, and then the median of all of these is 0.890. So what I want you to take away from this, and then I could also say the first difference result, which is 0.891, 0.892. So you see that these are very similar elasticities estimated. The important thing, though, is that this is much higher than what has been suggested in the literature before, reading off just a cross-sectional distribution in developing countries. It's also important that it's different from the non-experimental elasticity. So in this case, if we estimated off the cross-section, we would find an even larger elasticity, so around 1. And if you compare these two, you see that they are significantly different. So these are the two takeaways from the paper, essentially. So one, we need experimental variation to identify this correctly. And in this setting, the elasticity is higher than what we've typically seen before, so 0.9. Okay. And this is just, I mean, this is not exactly correct because we know that the elasticity varies over income level, but this is just to illustrate, evaluated at the mean. You see that the experimental curve, so again, this is budget share for food, and this is log expenditure. You get the steeper line with the experimental and the cross-sectional. So the cross-sectional shows a larger elasticity. Okay. So then to the group-specific elasticity. So we could be interested, okay, so if you transfer money, if you get an income increase, you spend on food, but what do you spend on within food? Is it also the case that you change from relatively cheap calories to relatively expensive calories? And this is indeed the case. So we see that so this is what I showed you already. This is food total. This is fish, meat, fish, dairy, and egg. This is fruit, vegetables, and cereals. And this is a miscellaneous category of other foods. So if you compare then meat, fish, dairy, and egg, which is relatively expensive calories compared to cereals, we find an elasticity of over 2, so 2.4. And here the non-experimental is actually lower. And for fruits, vegetables, and cereals, we find 0.6, and here the non-experimental is higher. So again, I want you to take away two things. So these are what we find for this particular setting. Of course, this may be context-specific partly, right? And then I want you to take away that the experimental elasticity and that identified in the cross-section, they are significantly different. So for all of these, except other foods in the first difference specification. Okay, so again, just to illustrate, you can illustrate at the mean, and you see that, again, this is steeper. This is also steeper for meat, fish, dairy, and egg, and then, yeah. Okay, so then to nutrients. So these are the ones I want you to focus on. So here's the calories, which has been the focus of some of Angus Deaton's work in India. And again, this is 0.753, so even though they substitute more towards other nutrients than calories, we find a much larger elasticity than what he found of 0.4. For protein, it's almost 1. For fat, is a little bit above 1. And these are about 0.6, so carbohydrate, fiber, and iron. Again, we see that for most of these, the experimental and the non-experimental are different. Yeah. Okay, so then back to this thing. Can we understand this difference? So it's very hard. and this is more sort of where we are now. We want to think a little bit through this. What can we do with the data? Try to figure out why the experimental looks different than the non-experimental. I don't think we can nail it down completely. We can say that these findings are consistent with some of these sort of confounding factors or problems in the cross-section. So the results are consistent with the poor caring less about food than the rich. So say that there is a preference difference. So say that there is sort of a tendency that the poor just care more about, I don't know, short-term pleasure, which is not food. I don't know, this is speculation. It is consistent with that, right, what we find. So we find that when you manipulate income, the response is larger than when you look in the cross-section. So it's sort of that in the cross-section, the poor is consuming less food relative to what you would expect from the experimental variation. Could it be reverse causality? It is consistent with reverse causality. So if you eat less, you're less productive, which could mean that in the cross-section we get that effect. But of course, when we manipulate income, you don't get that effect, like confounding factor. Okay, could it be a third thing driving both? Yes, and actually here we can test a little bit with the data. So we see that the poor, they have larger expenses as a share of non-food for funerals, for example. So it could be that if you're poor, you're also more sick, you have more expenses for funerals in the household, and hence you need to crowd out some of the food consumption with these expenses related to illness. But again, I mean, we don't have a very clear identification of this. So what we think we may be able to rule out, at least some kind of habit formation, I think we can rule out. So it's clearly not the case that they consume exactly the budget shares they consumed before. So it is clearly the case that when you manipulate income, they choose differently. So they substitute away from relatively cheap calories to more expensive calories. And also within, so the choice between food and non-food, they clearly shift. Okay. So this is, if you have ideas here, we would be very happy to receive them. Otherwise, I think this is more, if we want to nail down this full story, we need to design experiments where we can actually look at these things, to look at this more precisely. Okay. So concluding remarks. So we can estimate the income elasticity for food using random variation in income. We look at very poor households in a rural part of Kenya. It is important to use experimental variation, is one of the conclusions of this paper. We find a food elasticity higher than some previous estimates, but still below 1. And when getting richer, the households spend more of their budgets on meat, fish, and dairy, and less on fruit, vegetables, and cereals. And the elasticity for fat is around 1. So it's been sort of a magic number in this literature, whether the elasticity for food is larger than 1 or far below 1. It's a little bit unclear why this 1 is so important, because of course it also depends on this other elasticity. But anyway, that has been a magic number, and the only place we find that elasticity is above 1 is for fat.